Let's take up amines. First we are taking structure of amines. What are amines? Amines can be considered as derivatives of ammonia obtained by replacement of one, two, or all the three hydrogen atoms by an alkyl or aryl groups. For example, here one hydrogen of ammonia has been replaced by methyl group. So we get methylamine. Here one hydrogen of ammonia has been replaced by phenyl group. So this is aniline. Here two hydrogen of ammonia has been replaced by two methyl group. So we have got dimethylamine. First two are called primary amines and functional group in primary amine is NH2. NH is called secondary amine. Here two hydrogen of ammonia has been replaced by methyl groups. And if all the three hydrogen of ammonia are replaced by alkyl groups, we get tertiary amine. So this is the example of tertiary amine, trimethylamine. This is the structure of amine. Amines are pyramidal shape. This is the pyramidal shape of trimethylamine. Hybridization is sp3 and one of the sp3 hybridized orbitals has lone pair of electron. So this is the pyramidal shape of trimethylamine. All amines will have pyramidal shape like ammonia and they will have one lone pair of electron in one of the sp3 hybridized orbitals. Classification. We classify amines into three categories: primary amine, general formula RNH2; secondary amine, general formula R2NH. This R and R dash can be different. And tertiary amines, one nitrogen is attached with three alkyl groups, and these three alkyl groups may be same or different. So in tertiary amines there is N, whereas in secondary amine there is NH, primary amine there is NH2. Now we are starting with nomenclature. Nomenclature of some alkyl amines, that is aliphatic amines, aryl amines, that is aromatic amines. First compound is ethylamine. CH3CH2, there are two carbon atoms, we call it ethylamine. IUPAC name is ethanamine. Second one is normal propylamine. Why normal propyl? Because it is straight chain. IUPAC name propane 1-amine. Why? Because amino group is attached to the first carbon. Next we have isopropylamine. IUPAC name is propanamine. Now remember, in this compound, no doubt NH2 is attached to secondary carbon, but still it is primary amine. Because in secondary amine, the functional group will be different. This is the functional group of secondary amine. So NH2 will always be primary amine, whether it is attached to primary carbon, secondary carbon, or tertiary carbon. So this compound common name has isopropylamine. IUPAC name is propane 2-amine. So all the three are examples of primary amine. Secondary amine has functional group NH. So we are starting with secondary amine. With NH, one methyl group is attached, another ethyl group is attached. So this is unsymmetrical secondary amine. Common name is ethyl methylamine. IUPAC name is N-methyl ethanamine. N stands for nitrogen. And the two out of the two group, the smaller one is made as alkyl and methyl. And parent should contain maximum number of carbon atom. Here parent is ethanamine. So this compound is N-methyl ethanamine. Next we are taking tertiary amine. In tertiary amine, one nitrogen is attached to three methyl groups. So this is called trimethylamine. IUPAC name is N-dimethyl methanamine. Why NN? Because there are two methyl groups and they are attached to the same nitrogen. That's why we write NN. Two methyl group are taken as substituent. We will call it dimethyl. Parent in this case is methanamine. Next we are taking tertiary amine, in which two are ethyl group and one is butyl group. So the common system is name is N-diethyl butylamine. In IUPAC name it will be N-diethyl butane 1-amine. Now we have double bond as well as amino group. Remember, amino group will be preferred over double bond. So this is in common system, it is called allylamine. In IUPAC system, it will be called prop2-ene-1 amine. That is, this carbon which is attached to amino group will get preference. Next compound we have diamine, and here we have got 6 methylene groups, so we call it hexamethylene diamine. IUPAC name is hexane 1,6-diamine. This is one of the important monomer for nylon 6,6. This is aromatic primary amine. IUP common name is aniline, and IUPAC name aniline is accepted. We can also call it benzeneamine. This compound is again aromatic amine, aromatic primary amine. Here NH2 and methyl group both are present, so we call it orthotoluidine. It is also called 2-amino-toluene. This one is para-bromoaniline because bromine is attached to 4th carbon atom. IUPAC name will be 4-bromobenzeneamine. It is popularly called 4-bromoaniline, which is accepted as IUPAC name. This is aromatic tertiary amine where there are 2 methyl group and 1 phenyl group. So this compound is named as N,N-dimethyl-aniline. In the common system, in IUPAC system, N,N-dimethyl-benzeneamine is the IUPAC name. Now we are going to take up preparation of amines. Amines are prepared by the following method. First one is reduction of nitro compounds. Nitrobenzene, when reduced with hydrogen and palladium, palladium is catalyst, ethanol is used as solvent, we will get aniline. This reduction can also be done by tin and HCl, which will release nascent hydrogen, and that will reduce nitro group to amino group. Instead of tin and HCl, we can also use iron and HCl, which also will liberate nascent hydrogen, and it will reduce nitrobenzene to aniline. Nitromethane on reduction with tin and HCl or even lithium aluminum hydride will give methenamine plus 2 water will be formed. Nitroethane can be reduced with the help of lithium aluminum hydride. We will get ethenamine and water will be formed. Here SnHCl or lithium aluminum hydride, any one of them can be used. Next method we are taking ammonolysis of alkyl halide. That is, alkyl halide reacts with ammonia in the first step and we get substituted ammonium salt. In second step, this RNH2, this will break down into RNH2 plus HX. So RNH2 is primary amine. This will react with more of alkyl halide to form secondary amine R2NH. R2NH will react with another mole of alkyl halide to give R3N, that is tertiary amine. And tertiary amine can react with alkyl halide to form quaternary ammonium salt. The free amine can be obtained from the ammonium salt by treatment with strong base. RNH3 positive X, which we had got in first step, if we treat it with NaOH, we are going to get RNH2 plus water plus NaX will be formed. RNH2 plus water plus NaX will be formed. So this is the way how we can get primary amine by ammonolysis of alkyl halides. Here we will get mixture of amines, therefore pure amines cannot be prepared by this method. But if we want to control the reaction, we should take ammonia in excess. Instead of alkyl halide, if we take ammonia in excess, then we are likely to get mainly primary amine. Next we are taking reaction giving mixture of primary and secondary amine. This we are taking specific example and it is called Hoffman's method. Ethyl iodide reacts with ammonia. It results in the formation of ethylamine, which is primary amine. Ethylamine further reacts with ethyl iodide. HI is removed and we get secondary amine, diethylamine. Diethylamine further reacts with ethyl iodide. HI is removed, we get tertiary amine, triethylamine. Tertiary amine reacts with ethyl iodide to form tetraethyl ammonium iodide, which is quaternary ammonium salt. So this is Hoffman's exhaustive alkylation method in which primary amine, secondary amine, tertiary amine as well as quaternary ammonium salt can be obtained. Next we are taking Sabatier's method or ammonolysis of alcohol. Alcohol when treated with ammonia in the presence of Al2O3 at 350 degrees centigrade, water will be removed and alumina is acting as dehydrating agent. We get primary amine plus water. But if it's treated with another mole of alcohol, the primary amine will change to secondary amine, water will be removed. And if we take secondary amine and react it with alcohol in the presence of Al2O3 at 350 degrees centigrade, we'll get tertiary amine plus water will be formed. Methylation of ammonia. If we react ammonia with formaldehyde, in the first step you will get primary amine plus carbon dioxide plus water will be formed. Methylamine, if it reacts with formaldehyde again, we will get dimethylamine plus carbon dioxide plus water. And dimethylamine, if it reacts with formaldehyde, we will get tertiary amine plus carbon dioxide plus water. So by this method also we can get primary amine, secondary amine as well as tertiary amine.